Welcome to the webinar with our speaker, Dr. Susan Audino. Susan is a chemist and an independent consultant to chemical and biological laboratories. She has a lot of experience in method development, as well as an instructor for many of the ISO standards, including ISO 17025. Susan and I actually did some trainings together in the past where she presented the method validation aspect of some cannabis industry trainings. We had a lot of fun. I think it was in Maryland at the HLA headquarters. It was really cool. You know, Susan has a really rich background here, serving as an advisor or member of different committees, private and nonprofit cannabis organizations, as well as international standards groups like AOAC and their Cannabis Analytical Science program. And so, Susan, I think, you know, method validation accreditation is really important. But, you know, why chemistry? Why get into, you know, advising labs, working in the biological and laboratory space? I mean, it seems like you could have done a lot of things. Why cannabis?
So, you know, it's actually my second career. My first career was as a psychologist. So I hold advanced degrees in psychology and practiced for more than a decade, and chose to change careers. And nobody's more surprised that I'm in the cannabis space than me. I wake up every day and wonder, how did I get here? So one of the things that's really excited me about cannabis is that it is such an interesting compound. It is such an interesting plant. There are fascinating things going on in there, and being in the cannabis space, working in the industry, really unexpectedly, but gives me the opportunity to mesh my science. And so my graduate research was actually in physical chemistry for a while, kinetics and thermodynamics. So taking my interest in physical science and meshing that with my background in psychology, there's no better topic than cannabis. So through a series of events, I ended up doing a lot of auditing, laboratory auditing in the food industry, food and feed, and some of the more physical-based applications. But lately, cannabis is occupying probably 70% of my time. And for me, it's just really exciting. I get to meet interesting people, and my love of science being meshed with a very fascinating entity.
Thank you. Great answer. So if we could get on the Wayback Machine a little bit, you know, you've been in this field a while now, but what do you wish you had known or maybe invested some time in maybe 10 or 15 years ago when you were first, you know, starting off in the sciences?
So technically, I started off in the sciences long before then in psychology. And what fascinated me about psychology was neurotransmitters and why people behave the way they do and why things happen the way they do. And had cannabis been in the forefront of people's minds as it is today, I think I would have gone back and done more in the world of neuroscience. And even back 15, 20 years ago, when I made the move into chemistry, which was also a surprise to me, I probably, in hindsight, should have gone into, again, neuroscience. But for me, it's all good. It's all fascinating. I started to do pseudo neuroscience on my off time and learn from brilliant people such as yourself and other people I admire in the industry.
Oh, very cool. Well, you know, I really like that you said neuroscience, because on the one hand, you're out there helping to accredit methods and get laboratories having validated methods, which leads to accurate labels. But how those products and their ratios and their contents are affecting people, you know, the neurobiology of cannabis is such a contentious issue with no shortage of conjecture. for whether it's therapeutic effects on the brain or adverse effects. I really think that it's awesome to hear a chemist say that. But in your field today, there's kind of one or two questions I want to know before we get started. And one is, either, what's something that's true about the value of accreditation, method validation that few people agree on, or, what's the worst advice you hear in your field in the cannabis space? I'll let you choose how you want to answer that.
Oh, how much time do we have?
Just a few minutes. Pick your top two, maybe.
So one of the things that really bothered me is that we have an industry here. We have a new industry, a nascent industry that, although very well intentioned for the science, is also intended for making a lot of money. So it's driven by revenue a lot. And so as a result, I think the industry sees a lot of investors come in who do not have a science background, who are not chemists or biologists. And so they view testing, a third-party independent testing laboratory, as a money-making machine. And as such, I think that the advice they often get is, oh, just buy the instruments, buy the equipment, buy the space, and buy somebody who can come in, validate everything, teach you what buttons to push, and that way you just have to push buttons, get your sample done, and you'll make a lot of money. And I hear that advice over and over again, and over again, I see failure upon failure upon failure. And failure isn't just about the revenue. The failure is about false ideologies, and it's about a failed desire and a failed wish. So I think that is probably the biggest source of pain or discomfort for me in the industry as far as advice, bad advice that's given to people. And the other is that, we have a very young, energetic staff, a set of people who are working in the industry, and we don't necessarily have all of the experience to navigate complexities, especially those that are present with cannabis. So that's a little challenging as well.
Okay. Yeah, and I think that's a great point because, I remember when I had an undergraduate degree and there was a year between that and graduate school, and it was still difficult to, actually control some of your experiments and control what you were doing in the lab or have your expertise recognized. But, I think experience plays a large role in this industry. And so if it is a good rule to always just hire a PhD, whether they're newly minted or they have 20 years of experience, or is there also value that having a bachelor's in science? Is there a kind of a metric you might use there? So,
if you think about it, we have PhDs. Our PhD is in research, right? That's what it is. It's a doctorate in research and philosophy. And that research is, we have to show that something unique and novel works. And then great, we defend that, and onward we become doctors of whatever. In the third-party testing laboratories or in any kind of process or production laboratory, it's not about showing it once and it works and you move on. It's about developing a method that is going to be robust, that you are going to stake your reputation on, that you are going to stake your money on, that you are going to stake the consumer safety on. And we are not trained to do that in PhD school, in graduate school. So when we're looking at complex matrices, personally, I would rather see somebody with a bachelor's degree and 30 years of experience working in complex matrices than I would finding a PhD leading the brigade in a brand new laboratory where, I've been Dr. Audino for a year, let me go start up a cannabis lab. I never could have done that.
Nope. It makes sense. It'd be one thing to set up a research lab for cannabis. Right. Another thing else to set up something that's high throughput and extremely accurate and precise. And you might need staff that has experience. And some of our listeners have already chimed in saying, yeah, hire someone that has experience. Food experience, lots of matrices that they've worked with. So thank you, William, for those comments and joining the conversation.
We all have value. Everybody has value in the industry. And I think that value will be recognized when we put the value where it is needed. We have to speak to our individual strengths. And so if I want to think this laboratory year out of graduate school, great, I am well suited for that. But we have to recognize our strengths as well as our weaknesses and our desires, and put ourselves on the path that's good for our intended use and good for where we are.
I think that is brilliant, and that's probably why you made the list of top 20 cannabis chemists of all time from the Cannabis Scientist magazine. Is that?
Well, thank you for that, and I'm not sure, but thank you for that. I appreciate it. I appreciate the recognition.
No small feat getting on that list. And yeah, one of our listeners has chimed in saying, hell yeah, congrats. So with that, Susan, unless you have any other comments, the Q&A, I already have a couple questions for you, being familiar with your work a little bit. I'm definitely interested in your presentation as well. So let's let you get started. And everyone clap into your monitors and welcome Dr. Susan Audino, who's going to bring us some clarity to underappreciated numbers. Take it away, Susan.
Well, thank you very much. And thank you for the opportunity to be here. We all know that our test results have meaning, right? And I'm speaking on behalf of a third-party testing laboratory, the quality control laboratories. We all know that those numbers have meaning, and the way you pick up a bottle of soda or a bag of chips, you look at the label and you say, oh, this has so many calories in it. Do I really need it? Do I really want it? Or it has so much sodium in it. Do I really need it? Do I really want it? And likewise, people who are using our cannabis products are looking at those labels and saying, boy, let me make some decisions based on the results that are reported here on these labels. But we have to recognize that those numbers are the end result of many other processes that are often underappreciated. And that's hopefully, that's what I hope to talk about today, and invite all of your listeners here to look at things from a different perspective. So we're going to talk a little bit about method validation, method verification, measurement uncertainty, and what seems to be the highly coveted R-squared value. So, anything over a 0.9999999 is great, but is it really? So we're going to talk a little bit about that, and stick with me, okay? So when we talk about method verification and validation, first off, there is often confusion between the two, and from that confusion, we often have misunderstanding as to when to apply which one and then to what extent. In all cases, the results from verification and validation studies will lead to and really are the comfort zone and the confidence in our final test results, those results that we're putting on those labels and on the COAs. So let me throw this out at you. What percentage of your final test results are actually questioned by your customer? How many requests do you get for retesting? Many laboratories perform retests at their own expense. So what does that translate to? Well, it means it's free labor, it's free storage, you're giving away free reagents, free CRMs, free instrument time, and you're also stealing valuable instrument time from samples that you're getting paid to run. So all of this is very often, not all of the time, but very often rooted in inadequate method validation and or method verification. So some of the basic differences between verification and validation. Well, verification answers the question, does our lab use equipment and our own personnel to meet a stated method's specific requirements? Whereas validation answers the question, has our lab developed a test method that meets the requirements for its intended use? And usually that means, does it meet the customer's needs? So some subtle differences there, but here's a question, all right? Let's see where validation and verification might show up with these three conditions. So the provision of objective evidence that a given item fulfills specific requirements. If you quizzed yourself, you would know now that this is method verification. The confirmation that a target measurement uncertainty can be met, well, that's also method verification. And if our intention is to provide information that specific requirements are adequate for intended use, well, we're talking about method validation. In our industry, we're using more method validation than method verification. So let's talk a little bit about verification first. So we're talking about meeting all the specific requirements, and generally we're going to find these methods in a published method or a compendial method or a journal method, or very often a government issued or directed method. So FDA BAM, for example, comes to mind. So before we can use these methods on a customer sample, we need to ensure that the laboratory can meet these requirements using our own instruments, our own equipment, our own personnel. And remember that the methods that are published here generally specify a specific matrix. So for example, if the method is on wastewater, but we want to use that to determine something in a carrot, we need to demonstrate that the method still works for a carrot, even though it probably won't, but we can try. So if our intention is to use the same matrix, then we need to again demonstrate using empirical science. So we're going to come back to numbers to show that our equipment, our instruments, our personnel can meet those requirements. And sometimes it is necessary to re-verify some things. So things like you want to use a new CRM. For example, you want to use a CRM from a new producer, okay? Or you want to alter your matrix. So if you're used to tincture, but now you want to go to a beverage, perhaps it is the same method, but we need to verify that that shift in matrix is still working. It may or it may not, but we're not going to know that until we can have numbers and we have studies that demonstrate one way or another. So at a minimum, we're looking at changes in matrix and concentration range and reagents and chemicals as verification or potential triggers to re-verify, which has to be done based on the level of risk to the laboratory. Remember that the measurements have to be fit for intended use. And at the very minimum, we're looking to verify characteristics like precision and linearity and LOD. Remember again that the extent of this really depends on the risks to the laboratory and how much risk the lab is willing to accept. So we're all familiar with these. Anybody who's been to any of my presentations know that I pretty much always put up a list of performance characteristics that are relative to method validation, and here they are again. So not to disappoint anybody, but these are the method performance characteristics that not only demonstrate that a method works, but it also demonstrates, again, using sound science, that the method performs as it is intended to. Most of these studies require repeat measurements where you're going to calculate means and the degree of dispersion around that mean, so things like standard deviation. Method development and method validation really is not for the faint of heart, but it is critical. Okay? The studies here have direct input into the measurement uncertainty, which again goes into the confidence we put in and around our final test results. Unfortunately, most laboratories, many laboratories, especially in the cannabis industry, don't fully appreciate these performance characteristics and try to force the validation to meet a predetermined method, or to haphazardly perform validation studies to satisfy some regulatory or accreditation requirement. Or worse yet, our goal in the laboratory is to generate revenue, therefore we'll have to wait on developing a method. All of this will drive you to do a lot of retesting and compromises the integrity of your data. So as with method verification, there are certain events that could trigger validation or revalidation. And it's always difficult to predict exactly which parameter you're going to need to revalidate because it depends. So although not an exhaustive list, here are some common triggering events that could or should trigger a partial or perhaps even a complete revalidation. So periodically, a lab will come across a previously validated test method that is not a compendial method and then wish to import that into their own method. Maybe it comes from one laboratory with multiple locations, and location A developed a or validated a non-compendial method, and now location B wants to use that same method. So in this particular case, you would implement, the USP has a good guidance here, 1226, on method transfer. Okay. So although the differences may appear pretty subtle, they're actually kind of significant. Okay. So we have method validation, is it fit for purpose? We have method verification, does it meet requirements? And we have method transfer, which here is only valid for a non-compendial method. Here's a very quick decision tree. Okay. If you're using a compendial method, well, you're going to have to perform method verification. If it was not previously validated, so if it's a compendial method, it probably was validated. If it's a journal article, probably was not validated. If it's coming from your instrument provider, probably not validated. Then you need to perform method validation. If you're using a non-compendial method and you want to import this into your laboratory, then you have to evaluate that method, and if it was successful, then go ahead and use it, and use it with confidence. If it was not successful, then you need to revalidate. So this is all well and good, and we are now setting the stage to talk about measurement uncertainty. Okay. So the studies that we're doing in method development or method validation are going to lead us into measurement uncertainty. So again, it's old news, but always bears repeating that errors and uncertainty are not the same. An error is a difference between some measured value and its true value, which really can't be exactly known. Okay. The errors come in two basic forms, systematic and random. So systematic, measurement bias, remains fairly constant. Random errors really cannot be predicted. Okay. So measurement uncertainty has a specific definition, and it is defined by the GUM. If anybody has never read the GUM, it is a guaranteed cure for insomnia. It is the guide to the expression of uncertainty in measurement, and my graduate work was actually in chemometrics, and I did a lot of work in statistics, so I personally find the GUM kind of fascinating, but that's me geeking out. But the GUM does hold a lot of very valuable information. So uncertainty matters, right? We know this. We know that uncertainty matters a lot. Uncertainty is not an error, and it does not estimate error. However, uncertainty is quantifiable. So we look at uncertainty, and it should account for both measurement accuracy and precision, which are related to both random and systematic measurement errors. But uncertainty is integral in putting those confidence levels around our final test result. I'm always going to come back to the final result, which is the certificate of analysis that we're putting out there. So let's look at measurements A, B, C, and D here in the regulatory limit. So if we go above the limit, we're going to fail some specification, say, for example, a pesticide residue. And then below is an acceptable or passing range. So what do we know about measurements here in A, B, C, and D? Well, I think it's pretty safe to say that A is doing pretty well. It's within acceptable limits, and the same for B. Things start getting a little sticky when we talk about measurement C. So this has a sample passed or has it failed? Well, from where I sit, it seems that the measurement pretty much equals the limit. And although the measurement does not exceed the limit, the uncertainty band suggests that the true value really could exceed the regulatory limit. And so my question is, what do you do? And if we look at the regulatory limit in relation to laboratory D here, what do we see? Well, it seems pretty clear that the measured value does exceed the limit, but the uncertainty bands also imply that the true value may, in fact, be under the limit. So again, I ask you, what would you do? So let's shift our thoughts a little bit. Let's say I'm a customer that sends 3 aliquots of a sample to 3 labs. I know this would never happen in reality, but let's just pretend for a moment that it could happen. So A, B, and C end up with different results. I know it's hard to imagine. Okay. So let's look at A and B. Although the results are different and they have some uncertainty bands associated with them, are they comparable? Well, let's take a look at that, and I would say, yeah. So I could probably accept both of these results and attribute the differences to most likely some random factors. And when I look at lab B in relation to lab C here, there's a similar effect, right? So I can say, well, you know what? I'm looking at their uncertainties, and although the measurement values are a little bit different, the uncertainties kind of give me a little bit of warmth and comfort. So I'm okay with that. But then what happens when we look at A and C? Okay. We clearly cannot compare those results. And if we look at the uncertainty bands around A, they don't even come close to the measurement or the uncertainty of C. So here we have a case where 3 labs, 3 aliquots, 3 different results. I'm confident I could put some confidence around A and B and C, but I cannot draw a conclusion between A and C. So things to keep in mind. All right, so let's talk a little bit about measurement uncertainty and how to determine it. Every measurement is an estimate of the value of the measurand, or in our case, usually it's the analyte. So measurement is never exact. And again, the difference between measurement and true value is an error, not uncertainty. And uncertainty gives us a probability distribution for the true value. And to calculate this, there are 4 basic steps. The first is always to identify or define the analyte of interest. The second is to identify sources of uncertainty, and then also some components, because a source of uncertainty is not always direct. For example, if we want to look at uncertainty associated with sample prep, what elements go into sample prep? So we're talking about uncertainty in storage, uncertainty in sampling and subsampling and test location and pipettes and balances. So we then have to look at classifying types of uncertainty as type A or type B, and we're going to get to that in a little bit. Okay. Then we go into identifying or quantifying the individual components of uncertainty, and then we evaluate the combined uncertainty. So again, let's look at some potential sources of uncertainty. We look at just sample prep, all of these elements go into it. We look at sample properties, we have some of these elements, and this is in no way, shape, or form an exhaustive list. So this is just here as an example. But again, our one source of uncertainty here, sample prep, includes other stuff. Okay. So sometimes it's helpful to establish a fishbone diagram, and I'm going to get to that in a second. But first, let's look at some uncertainty categories. So we look at type A, and these are generally obtained from statistical analysis of repeated measurements under the same condition. So a lot of what we're doing in method validation would fall under type A. So we're looking at operator and sample prep and instrument settings and accuracy and precision. And type B are categories and measurements from other sources, and these are often referred to as deterministic. So we're going to find this information and this data on things like calibration reports and certificates of analysis and specifications and tolerance. So for example, almost every laboratory uses Class A volumetrics, And when you buy your Class A volumetrics, you're buying a tolerance, state of tolerance associated with that. So we can also get some information from instrument manuals. All right. So let's back up here to step number 2. Okay, identifying sources of uncertainties. So we look at the individual uncertainties here. We're looking at, let's say, balance and a volumetric pipette and standards and matrix or matrix storage. So what goes into a balance? Well, individual contributions into a balance uncertainty include things like resolution and accuracy and the calibration. Volumetrics, again, calibration, tolerance, and temperature, because remember that temperature of our water and how we're measuring a pipette or volumetric could be affected by the buoyancy in the air. So we're looking at standards. So standards are not pure, right? They have a certificate associated with them. So we're looking at usually purity. We're looking at balance. Okay, so balance is a contribution to the uncertainty of a standard, and so on and so forth. So I think hopefully you are beginning to recognize all of these pieces. So before we can identify the uncertainty of the balance, we need to identify the individual components or contributions of the balance. So we have to calculate these individual contributions. So I do want to tell you that what is not in this slide deck, because there is a whole class on it, and I'm happy to sit down and teach people individually, but there are also a host of calculations that go into these, and especially for some of the type Bs, things depend on probability distribution. So we're going to talk about rectangles and U-shapes and triangles and a whole bunch of other things. So I am hopefully making a lot of people happy by not giving you all of that information here. But know that we have to do that. So these are the fishbone diagrams I was talking to you about. I just copied this from the Journal of Brazilian Chemistry, but we can build our own, and every laboratory should build their own. But this is a good example of how we look at one source of uncertainty and then build out all of the individual contributions. So after we've done all of that, we have to calculate the standard uncertainty. Okay? So we're going to look at taking what we calculated for the uncertainty of the balance and the uncertainty of the volume and uncertainty of the standard and the storage. And then we're going to take all of that and calculate a combined uncertainty and then an expanded uncertainty. And so the combined uncertainty is a combination of all of those others that we've calculated in steps 2 and 3. And then we're going to move to expanded uncertainty. So combined uncertainty is really the square root of the sums of squares for the balance, the volume, the standard, and the storage. Pretty much all of the uncertainties that we're doing are essentially the square root of the sums of squares. However, in order to put some confidence bars around all of this, we need to calculate the expanded uncertainty by taking combined uncertainty and multiplying it by an appropriate coverage factor. And people ask all the time, what in the world is a coverage factor? And I remind people that you absolutely remember and know what a coverage factor is, although you may not remember it. So remember these graphs, go back to that one stat class that you took way back when. So this is a normal curve. This is a Gaussian distribution, right? And our goal is to identify how confident are we in our result that we are 95% sure that our result falls within the true value here. So a coverage factor of 2 is 95.4%. And if you remember things like t-tables, we're talking, a t-score here would be 1.96 plus or minus. So if we just round that up to 2, we can. So that is your coverage factor. And so our expanded uncertainty is to take the combined uncertainty and multiply that by the coverage factor, or K. And almost all of our work in Cannabis is requiring us to look at a K factor of 2 so that we have a 95.4% 0.4 approximated coverage. Okay, I hope that helps clarify things a little bit when we get to uncertainty. All right, finally, I would like to take the opportunity to discuss that highly coveted R-square value. We all know what it is. R-square has to be more than 0.99 in order to be good. Well, I'd like to provide you the invitation to consider a perspective that R-squared in its isolation is not always the best approach, and that by blanketing your acceptance on just the R-square value is actually creating a risk for you. So this is a calibration curve, right? This is our linear interval. Our slope is the sensitivity, and the laboratory develops a bunch of standards, and then we do a best point line. We know this. So we take that y equals mx plus b, and we create calibration curves, right? So let me ask you, we have three curves here, A, B, and C. If our definition of a good calibration curve is 0.99 or better, do these all pass? And I would say, yeah, it probably does. Okay, but we're using a best fit line, which, remember, does not go through all the points. So we use it to calculate our standards, the things that we put up on that line that we are going to use to tell us what an unknown concentration is. So how much confidence do you put in all of those values? Well, after we calculate our calibration curve here, we do our calibration curve here, we can use that equation, that y equals mx plus b, to go back and calculate our initial concentrations, or what we thought were our initial concentrations. So what we should be doing is analyzing not only the y, but also the y hat. So that calculated concentration in red there on the right columns of each of those curves is actually a y hat, which is the observed, or predicted value. So now we have a little bit difference, right? So now are we looking at A, B, and C with the same cherry rosy eyeglasses because they all meet our criteria of R-square greater than 0.999? And so we can see where things are being leveraged by an upper point, especially in A. So if we look at, where's my pen? If we look at A here, hang on a second. Uh-oh, what did I do? Okay, so if we look at this point here, that point is leveraging the line and the curve for all of those other points. It has an effect. Same thing here. So we're looking at a dynamic range that is going from, let's say, 0.1 whatever unit to 1,000 units. We are looking at challenges. We are looking at potential threats to the assumptions of this linear regression model. So we don't always remember that linear regression is actually a model. It doesn't tell us about an absolute relationship. So there are certain assumptions. One is that residuals, which are the differences between y and y hat, so what we predicted to be the concentration and what we actually observed as the concentration, those are the differences. That should be 0. Okay? And that those residuals, or those errors, should be a mean of 0, and they should be random around that mean, and they should have equal variance. How many of you actually plot your residuals? My guess is very few, if any, and as an auditor, I often go into a lab and I can tell them where they're going to have problems with retests and their test results by just looking at the calibration curve and looking at the dynamic range. And what usually happens is I can see a violation of the assumptions around this model. And the first thing I do is plot the residuals. And so here's an example of what residuals should look like. So this is random. This is what they should look like. Okay. When they are not random, this is one possibility is we get this U shape, or we may get an upside down U shape. These are non-random, and there are other examples of what a non-random distribution of residuals looks like. So I encourage everybody to explore and carefully examine your residuals, especially during method development. Possible reasons for these non-random residuals are things like the linear regression is incorrectly fitted through zero. So if you are forcing your calibration line through a zero, we're probably going to see some issues with your residuals. Or maybe the instrument response will always increase with analyte concentration or always decrease with concentration. Or maybe the linear regression line is incorrectly fitted through what is non-linear data. So, what is the credibility of underappreciated values and underappreciated numbers? Well, first off, we'd like to avoid type 1 and type 2 errors, especially in the marketplace, right? Because we are making judgments and we are directly affecting cannabis business by our test results. So we need to be very careful about what we're providing them. We have to recognize that a test result alone does not provide credibility, that it is based on a foundation that begins with method development and method validation. So here's our mean measured value. Here's the true value. We have some systematic bias that we need to try to account for. We have random stuff going on that we need to account for. And then once we bring all of this together, we're hopefully going to provide a value that is bracketed by a 95% coverage or 95% confidence in our results here. So we're generally going to get a lot of this from precision studies, method validation, method verification. So when we evaluate a test result, our goal is always that those test results are inside of a very well-defined net, and that net or that scope goalpost is established by decision rules and precision and accuracy, uncertainty, and action limits, just to name a few characteristics. So looking at a test result in isolation is not doing the laboratory a service and does have direct effect on the veracity of your quality, of your certificate of analysis that you are attaching to a product. And with that, I would recommend looking at some references. So these are some of my go-tos. These are sources that I am always referring people to. One is Eurochem, a CTAC guide. Another is a textbook. What I like is that they are very aligned with 17025 and do a very nice job of quality assurance and analytical chemistry, and a few other sources out there. So I would recommend that laboratories get their hands on some of these, and if you are not feeling comfortable or confident doing the work, then look to a qualified consultant or take a good class. Once you do it and feel comfortable around it, it does get easier. The first time it looks pretty scary, and it's just a matter of gaining confidence. And the more confident you are in establishing uncertainty, the more confidence you will have in your test results. And so with that, I'm happy to respond to some questions or comments or anything else.
Oh, thank you so much, Susan. Real quick, we'll take a little break here just to thank our sponsors. Let me get the slide up. All right, just while Susan catches her breath from that talk, I hope you all are taking this moment to start plotting your residuals. But we'd like to thank our sponsors, Heidolf North America, Perk and Elmer, as well as Carbon Chemistry for making these events possible and helping to fund CAN's efforts. And as a reminder, we have some more journal clubs coming up, April 28th with Dr. Linda Klumpers, who again has a background in pharma aspects and drug development aspects related to cannabinoids. We'll follow that up May 28th with Monica Tang, who's a PharmD, has a lot of practical experience and the pleasure of presenting with her at Columbia University last year. And I'm looking forward to something a little bit different on June 30th with Rod Kite, who was named Attorney of the Year last year in the cannabis field. And he's going to be sharing his insights about DUIs and analytical testing issues related to establishing those regulatory thresholds. Again, ACS Philadelphia presentations are coming soon in online format. Canned proceedings from the San Diego meeting will be released in April. And we still have an open call for abstracts for our online efforts, including a session I'm putting together on aspects of what happens when the FDA and other federal agencies start to regulate cannabis, what happens when the pharmaceutical industry starts investing more in cannabinoid drug development. So there's some really interesting sessions open, and if you haven't yet, join CAN today. All right, Susan, I hope you're ready for all the Q&A coming your way.
Yes.
But the first, you mentioned that resource slide, and so the first thing I want to ask you is, of the resources you share, the textbooks, what's the thing you share the most often with people? For me, being more on the research side and the biology side, I have a folder that's an iterative folder of 5 studies. And as I see new ones, I cycle them out. But those are the studies, my go-to studies that I send to people when they ask me about cannabidiol or implications of cannabis regulation, whether it's regulators or doctors. What about you? What would you say is like the most common thing you share with people who want to learn more?
Method validation, mostly these textbooks. Depending on a person or a laboratory specific need, I may put them in touch with specific individuals. There are some go-to experts, and I like to refer to them whenever possible.
Well, speaking of those go-to experts, over the last year or two, who do you learn from? Or are there people you closely follow in this field or other fields that help inform, help inform what you're doing?
Yes, so one of the newer areas that I didn't get into in the slide is things like target uncertainty. And so this is sort of backing into uncertainty from kind of a reverse approach. So we're kind of establishing what the limitations are and then calculating to meet those. So that's something that's a little bit new to me. So I'm enjoying reading about that. But I spend a lot of my time really entertaining my personal interests, which is, again, the neuroscience. So my go-to are people like yourself and Ethan Russo and folks who are continuing to do really exciting research and reporting on that research, such as what you're doing with the journal. So it is helping me understand on a more internal or physiological level what actually is going on, and to me that's for me more interesting than anything else. So, you're one of my go-tos, Jehan.
Oh, thank you. Well, if you guys don't have my email or contact information on this webinar, feel free to reach out. Thanks for the endorsement. So William Scanlon has a question. He's asking for a friend who wants to know, how does one get into auditing laboratories or assessing laboratories? Do you need a PhD to be able to do laboratory accreditation or consulting on accreditation? What are your thoughts here?
So no, you do not need a PhD to do laboratory accreditation. However, you do need to have some expertise in laboratory science, and you need to have demonstrated your expertise and experience in laboratory work. And then you apply to an accreditation body, for example, ANP or EQLA, and you submit an application. And through that application, the accreditation body will likely determine their need and then may or may not invite you to take assessor training. So that's where you can get into that, but it's not let me take a class and then go out and be, an accreditation laboratory assessor. So, for example, we are qualified based on our expertise. So I'm qualified for cannabis labs and tobacco labs and semiconductors and refinery. I am not a qualified assessor for things like calibration laboratories or mechanical laboratories for the most part.
Okay. And I guess a follow-up to that, unrelated, but still a follow-up, I feel. As an assessor or accreditation officer, or maybe in your capacity as a consultant, when you go into a facility, I've had experience doing, certification assessments and some ISO 17025 at labs. I certainly have my own stories about this, but I don't know if there's one thing you could share about a weird experience, an unsettling experience, maybe an extraordinary experience you had doing some of this work in a facility.
Oh, sure. So one of the requirements of accreditation is that you have the resources and tools that are necessary to do the job that you want to be accredited for. And I walked into a laboratory for their very first assessment and said, "Where are the instruments?" And for that matter, where are the people? And so, yeah, that was not that assessment did not go through that day, and that particular laboratory had quite a bit of work to do before I could go back and actually do an assessment.
Wow. So I think that's a great advice. Don't schedule your assessment until at least you have the instruments in the facility. Okay. I mean, who knows? Maybe they thought you'd do a walkthrough of the physical building. Very interesting. So we have a really, this a bit of a longer question. I'm going to try and summarize from a Mr. or Mrs. Anonymous attendee, whose question, I'm going to read the question first, and then I'm going to provide some of the background. And this participant asks, do you have advice for us chemists who want to do the morally right things and help progress the cannabis industry? And what they're talking about is, here's a chemist that has 5 years experience, FDA, ICH lab experience, and been working in the cannabis industries, but is going to companies that have no experience with owning labs. They expect things that aren't realistic. There's issues with pay and healthcare and benefits. And sometimes it's hard for chemists to stay strong and fight the good fight, knowing which companies will succeed, which ones won't. And, worried about your resume if they're jumping from lab to lab because they're not staying somewhere. With all of this, as you're peeling this onion, we still want some of the onion left, but if you were to peel some layers off of this, what sort of advice would you give for these young chemists? And maybe it's advice you would have given to your 25-year-old self going into this industry.
Yeah, I wish I were 25 going into it.
Oh, we'll continue.
So this is not uncommon, and I keep approaching this from an educational perspective in that the folks who are driving the laboratories, never in any other industry have I run across so many laboratory owners who are not scientists. So from, on their defense, they don't know any better. However, they should know better, right? So my advice to the chemists is it's all about education, and the lab owners, lab directors need to have more understanding, and they need to have a solid understanding of what's going on. And unfortunately, you're probably not going to be the person who they're going to listen to. And so my advice is when you're out looking for a job, remember that a job interview is not just about the prospective employer interviewing you. It's also an opportunity for you to interview the employer, the potential employer. And so put some of this out in a relationship. You have to be as comfortable about that relationship with that person and that organization as they are with you.
Okay. All right. I think we got another question coming in here. Dr. Mark Scaldone, one of our CAN members and Cannabis Chemist Extraordinaire, has a question here. What level of internal in-house testing capabilities do you recommend for producers who are required to do third-party testing to have? This is something I encountered a lot, was I was always surprised how many vertically integrated facilities did not do any internal testing before they sent their products off. And of course, method validation and this sort of in accreditation methods plays a role. But what would you say to someone who says, what level of in-house testing should my cultivation production facility have if we're sending products out for third party? I mean, I always assumed it was kind of, you wanted to have an idea of what to expect from the testing lab. Because if they said, oh, you have a bunch of THCV in your product, you'd be like, we've never seen that in our product. You know, just as an example, but what would you comment on the level of internal house testing capabilities that you might recommend to a producer?
So to a producer, an in-house third-party testing laboratory is not uncommon. In fact, most pharmaceutical laboratories, many manufacturing laboratories, many food laboratories have their own in-house third-party 17025 testing laboratories. The risk is that your only customer is yourself, is your production laboratory, and so it requires a division of expertise and a division of expectation, in that the laboratory facility is producing on one side of the building and then doing 17025 testing on the other side. So it's not uncommon. It is uncommon in the cannabis industry, but it's not uncommon in the rest of the world. There is also a risk, and if we're very astute to those risks and paying attention and transparent, it can be done very, very successfully. However, if you just want to keep an eye on what's going on production-wise, and you're still sending your samples out, your products out to a third-party lab, then there are other instruments that you can buy to do that. So things that I recommend are things like an NIR, for example. I think an NIR for a production facility is great. However,
and these are those handheld devices that can kind of give you a yes or no answer, like, is the THC decarboxylated from step A to step B, that sort of thing?
That's a very big generalization, but
for conceptual purposes only.
For conceptual purposes, sure. So, you know, it has its utility in that particular environment, but it's not something that I would recommend in a, you know, to put on a COA.
Okay. Great. And following up to that, one of our participants has another question. KP, am I saying that right? KP. What should a company look for when they're looking at a lab to run tests for something like an infused product, not a flower matrice or, you know, but an infused product, maybe something a little more complicated matrice that would help them be more confident in the results? I mean, I would assume naturally it's a validated method for the thing that they're testing. But are there some other things that aren't so obvious? Obviously, you want the lab to have equipment and instrumentation in the facility.
Yes, ideally, what you want to look for is an accredited lab. 17025 is a great standard. I believe wholeheartedly that laboratories should be accredited. However, I also acknowledge that 17025 as a standalone qualifier is insufficient, because 17025 doesn't tell us to use the best science. It just says to use the best that we can do for the science that we choose to use in our laboratory. So we have to look at the laboratory. What are they using? What is the technology that they're using? I can go to 2 laboratories that are using, you know, one is accredited for reading smoke signals, for example, and another one is using this $4 million piece of Acme equipment, but they're both accredited. So we'll come back down to our, you know, what exactly are you looking for? What exactly is the method validation process that the laboratory is following? Now, the laboratory may not want to disclose to you exactly what their data were or what their method is. However, you can ask and should ask, show me your procedure for validating a method. So what is acceptable? What are you going to allow or not allow? You can ask for technology. So there are things that you can look for, and also ask for things like, how many samples do you usually get requested to retest? Which I ask that question all the time, and most laboratories don't chart that, which blows my mind. I don't know why they're not charting.
Why would you say that that is important?
Well, it tells us a couple of things. One is on the laboratory behalf, on the laboratory side, it is giving them a window of how much of our materials are we giving away and retest something, right? Those
So
are
the economic factors, yeah.
there's the economic factor, absolutely. But also, if a laboratory is testing 100 samples in a day and 50% of them are being requested for retesting, perhaps the method that they're using to test might not be the best. So tracking, how many samples you're retesting and why, and doing an investigation as to understanding why are we being requested to retest. And, granted, a lot of that may be driven by the consumer and not so much by the laboratory, but the laboratory should have a much more solid understanding of the potential laboratory issues that are involved in that.
Interesting. Okay. We're nearing the end. I have one or two more questions for you. And I want to test the philosophy side of your training here. So again, this is just have fun with this question, but if you could have like a pop-up ad that could say anything you wanted anytime someone went to, say, a cannabis website, pop up, and it had a message on it, what might that message be? Or if that's too digital for you, think of it as a billboard. But I like, in the modern age, if I could design a pop-up window and people go on a reading about cannabis, that would pop up and be like, hey, did you know? Or
I would go back to just one of my last slides, which was a soccer net with your test results in it. And that test result is bracketed by all of these other parameters that have to be characterized. That tells the story about the test result. So if I could have anything, I guess it would be that.
Yeah, I really like the goalpost analogy. As a soccer nerd myself, they've done calculations where if they just move the goal post, 6 inches wider, I mean, it would change the game of football. There'd be there'd be an exponential increase in number of goal scores. It would truly change the game in terms of the amount of accuracy and precision that's required to, have a successful match or testing in this situation. I guess, getting down to the last question, second to last question, is there anything about cannabis, that you've changed your mind about in the last 2 years or so? That maybe you had a preconceived notion, maybe you're pushing for a standard or not realizing a standard was needed, or I don't know, I'm just trying to think, what have you changed your mind about in the last few years?
What I have changed my mind about is that, when I first got into all of the cannabis stuff, which just shocks me, I'm astounded every day that I'm in cannabis. That's a whole other story. But I believed then, and I believe now, that everybody is very well intentioned. However, one thing that have changed my mind, I guess, or maybe refined my thought process on, is that not everybody who is well-intentioned should be making some of the decisions and providing the guidance that they are doing. Just because you're interested in something doesn't make you qualified to do something in particular.
I'm fascinated and interested in brain surgery and neural implants to fix conditions, but I'm not going to be administering those procedures anytime soon.
I'm happy to talk about method uncertainty, measurement uncertainty, but I'm not, it's not my expertise to go out and tell you how to plant the plant and how to foster growth. That's us.
All right. Well, as we're getting near the end of time here, so I would just ask you, are there any asks or requests for, people watching this webinar? Any last parting words for people?
Method development, method validation. Oh, and if I haven't mentioned it before, method validation.
So you've mentioned method validation before. No, so thank you everyone for your time and attention and submitting your comments and questions. Susan, we got a lot of great feedback. A lot of people thought this was a great topic, some discussion going on about testing in the workplace. So thank you so much for your time, your attention, your willingness to field my random list of questions for you.
My pleasure. Always thank you for the opportunity. I've really enjoyed the last hour with you folks.
All